Hello, good morning, guys. So in the last class, we discussed about DHCP relay agent. Then we discussed about DHCP snooping. After that, we discussed about dynamic ARP inspection. Then we discussed about SNMP and syslog. And we discussed about triple. These are the concepts we discussed yesterday. So the DHCP relay agent, why it is used? It is used whenever your DHCP server is available in a different network. When DHCP server is available in a different network, means not in the same network. And when it is in the different network, means it will be separated by router, and the broadcast messages like your discover, offer, request, and acknowledgements, they will not be passed by the router because they are broadcast message and router breaks the broadcast domain. So router will never forward a broadcast message from one interface to another interface. So the discover and all these DHCP messages, they will not be able to exchange. So the systems, the clients, they will not be able to get the IPs. So your router has to act as a relay. And for that purpose, we use the concept of DHCP relay agent. In this case, we always go on the client side interface of the router. Then, for example, if it is 00 by 0, and you'll say IP helper address, and then you give the DHCP server IP. This is the configuration. After that, we saw about DHCP snooping. So DHCP snooping, when it is used, remember, whenever you have a rogue DHCP or fake DHCP server in your network. Okay. So to prevent rogue DHCP server in the network. So your DHCP snooping will only allow DHCP offers from a trusted port. So whatever your trusted port is, you will go to that interface, and in the DHCP snooping, you will configure that port as the trusted port. Okay. And remaining other ports, if there is a DHCP offer from other ports, your switch is going to drop those messages. Then we have dynamic ARP inspection. This is used to prevent like attacks like your ARP spoofing. Okay. Or you can say to avoid man in the middle attack. Okay. So this your dynamic ARP spoofing, and dynamic ARP inspection, it is going to make use of your DHCP snooping database. DHCP snooping binding database. And it is going to compare the ARP messages with this database. If there is an entry in this database, the ARP messages will be forwarded. Otherwise, those messages will be dropped. So if the attacker is not able to send the ZARP and not able to manipulate the ARP cache of the systems, means there will be no man in the middle attack. Okay. Then we saw about SNMP and syslog. These are two monitoring tools of our network. Okay. Syslog works on push mechanism, means it is just going to push you the information. Whatever changes have happened already, those changes it is going to display. While your SNMP works on the poll and resource mechanism. Means if you want some information, you can ask for that. And if there is a, you can say if there is a event, okay. If there is some sort of event, then your SNMP agent is going to send that information through the alerts to the SNMP manager. And the manager is going to send alert to the admin. Then your syslog will give you historical data, means you will get a log only if something has happened already. Otherwise, you will not get a log. Means if an interface is already down, then only you will see that the interface is down. That message you will see only that. You will not see that why interface is going down. But in case of SNMP, you will get the real-time information. Okay. Then we saw about AAA. AAA stands for authentication, authorization, and accounting. Authentication means verification of user. Before providing access, verifying whether the user is correct or not, using usernames and password. Authorization, defining level of access. That once the user has been authenticated, how much access the user has on the device. What are the tasks the user can perform in the device. Okay. So defining level of access. Then accounting. Accounting is keeping a record of everything. Everything performed by the user. This is what is your accounting. Okay. What time the user logged in, how much time the user was having the session, what were the comments, and what was the consequences of the comments, what was the output of the comments, everything will be recorded. Okay, so this is what your AAA concept is. This is clear. Today we'll be starting with IPv6. We'll see what is IPv6, what are the address types, and then how you can perform IPv6, like how you can assign IPv6 addresses, and how you can perform routing in the IPv6. Okay, so when we started studying about IPv4, I gave you a difference between IPv4 and IPv6. I think everybody remembers, right? So tell me those differences. IPv4 and IPv6. You need to fill with the prices, huh? Yes. Yes.
In IPv4, there are 4 octets.
More number of addresses in IPv. Okay, first of all, let me give you an example. We'll not see the examples. So first of all, I'll give you example. I'll show you how a IPv4 address looks like and what an IPv6 address looks like. And after that, we'll see about the references. Okay, just looking at these addresses, what are the differences you can find?
They are separated by dot and they are separated by column.
Okay, let's go with the bits first. It is 32-bit. And this one is 128-bit. Okay, next.
4 octet.
4 octet. Having 4 octets. And 8 octet or hexstate. Okay, then separated by dot, and this one is separated by. Okay, then what else?
1 octet equal to 8 bit in IPv4.
Okay, so 1 octet equals to 8 bits. And IPv6 equals to 16 bits. Then decimal and hexadecimal.
0 to 9.
Decimal means 0 to 9. And here hexadecimal. So 1 will be 0 to 9. And
A to F.
A to F. Okay. Anything else? No? Yes. Range. How? If we define IPv6 range, that will be a really big range, right? So your IPv4 has 5 classes. IPv6 doesn't have any classes. There's no class A, B, C concept. Okay. There's no classes in IPv6. Okay. Then you can go with the number of addresses. You can say there are less number of addresses in IPv4, more number of addresses in IPv6. Okay. But these are some of the common differences. So from here, IPv6 introduction, we get that it is 128-bit. There are 8 hex states. In 1 hex state, there is 16 bits. Okay. Then your IPv6, it is separated by colon, and hexadecimal number system is used, means you will have numbers as well as letters. And then there are no classes in your IPv6, means no A, B, C, D, E class. Okay, and there is no subnet mask concept in your IPv6. There is only CIDR notation, means slash value. No subnet mask. You don't have to write 25 by 25 or something like this. Nothing. Okay. You don't have to write anything like that with the help of with the IP address. You will always be writing it in the slash value. Whether you are assigning the IP address in system, router, anywhere, it will always just be slash value. Is it clear? Okay. So these differences are clear. Okay. Now let's say you have been given an IP address. Before that, let's check. So total number of addresses in case of your IPv4, it is 2 raised to power 32. So the value of 2 raised to power 32 is this value, around 4.3 billion approx. Okay. And this is the value for 2 raised to power 128, means the actual number of addresses in your IPv6. And this is why we call it as an infinite, because there is huge number of addresses in your IPv6. This is clear, right? Okay. This number we do not need to remember. This is not for remembering. Then size difference. Your IPv4 it is 32-bit and IPv6 it is 128. Next difference about octet, hexstate, and dots and colons. So in IPv4 we have octets, so 4 octets. In IPv6 we have 8 hexstate. IPv4 separated by dot, IPv6 separated by colon. And this is the binary conversion. So how you can convert your hexadecimal or IPv6 into binary? Let's understand. For example, let's say you have been given an address. Same address I'll take 2001 colon 0db8 colon. Let's say this is the IP address and you want to convert it in binary. So this is hexadecimal number system. We have seen binary to decimal conversion, but not binary to hexadecimal or hexadecimal to binary. Okay. So what is the first octet, first hex state value? 2001. So see how you're going to convert this 2001 into binary. So we know one thing, that in each and every part, there can be how many bits? 16 bits. Means what could be the possible value of one part? 4 parts. There is 4 values, right? They are having 16. So means value of one place will be 4 bits. So means I have to write this one value in 4 bits. Means if I'm converting this one number in the binary, I will write 4 bits. Okay. So again, the same method, 1, 2, 4, 8. 4 bits already. Okay. Now I want to create the number 2. So if I compare 2 with 8, larger, cannot take it, 0. Again, compare 2 with 4, again larger, cannot take it. 2 with 2, same, 1, and then subtract. 0 means no number left. So this is also 0. So means binary of 2 will be 0, 0, 1, 0. You will write 0, 0, 1, 0. What is the next number? 0. So binary of 0 is all zeros. So means this one. Again, next number is 0. Then again, next number is 1. This is binary for 2001. This is binary for 2001. So why we are writing 4 bits? Because it is hexadecimal, means each and every place can range from 0 to F. Right? If you write F, what is the value of F? 15. Convert 15 in binary. If you convert 15 in binary, you'll see 8 plus 4, 12, 14, 15. So this is the reason we are writing 4 bits for each place. Because maximum value of any hex state can be FF, FF, right? Because it is hexadecimal, not a decimal. Okay, this is done. Then the next, right colon. 0 means all zeros. Then we have D. So according to our calculation, A is 10, B is 11, C is 12, D is 13, E is 14, and F is 15. So next number is D. D means 13. So 8 plus 4 plus 1. This is the value. So means 1, 1, 0, 1. Then B. B is 11. 8 plus 2 plus 1. Correct? Means 1, 0, 1, 1. Then 8. For 8 means 1, 0, 0, 0. Then we have 0. Again 0. Then 1. Then again 0. Correct? After this, again colon, all zeros. Again same thing. So 1, 2. Then one more hex state is all zeros. Then the last octet is all zeros and 1 means, is it? So we can convert hexadecimal into binary. So for each part, you see 4, 4, 4, 4, 16 bits, and 16 8 times is 128. So this is how we can convert it into binary. Is this clear? Huh? Yes. 8. So 8 is what? Compare it. 8 with 8. 1. Subtract it. number will be 0. No number left means remaining all will be 0. So 1 0 0 0. Clear? Any doubts? No? Online people?
Yes.
Is it clear? Okay. So means if we convert it in binary, this number will be 0 0 1 0 0 0 0 0. This is one exit. And if it is hard to understand, you can just separate 4 4. So it will be easy to understand. After this, D value is 13, means 1101. B value is 11, 1011. Then D value is, 8 is 1000. Then again, then we have all zeros and 1. After this, we have all zeros. And this is more 2 times. And the last part is all zeros and 1. So this is the value of your IPv6. And this is how it is 128 bits. Clear? Okay. This is what binary. This is clear? Any doubts? Then next what we have? IPv6 shortening. Means you see right now this is a big address. Right? In binary it is very big. Even in hexadecimal also looks big. So what we can do? We can shorten this address. So how we can shorten this? So your address is, you have been given 2001 colon 0db8 colon 00. Now let me change the address. This is the address. Now we want to shorten this address. So to shorten it, the first rule is eliminate starting zeros in each hex string. So you have to remove all the starting zeros. Once you remove all the zeros, so in 2001 there is no 0 in the starting. We cannot remove it. So this will be 2001. 4 times 0. So we can remove starting 3 zeros and we can keep 1 0. Again 4 zeros. So I can remove starting 3 zeros and keep 1 0. In the 0 db8, I can remove the 0 and keep db8. Then again 1 0, again 1 0, again 1 0 and 1. Address became short. Correct? Now what is the second rule? Replace continuous colon, continuous 0 hex states with double colon. Means anywhere continuous 0 hex states are coming, we can replace it with double colon. Okay? But double colon can be used only once in an address. Means we have to use double colon only once. We will not use it again and again. So if we shorten it according to the second rule, so what will be the address? Either we can shorten it like 2001, then we have 2 continuous zeros. So means I can replace it with double colon. And then I can say db8 colon 0 colon 0 colon 0 colon 1. Why I'm writing 3 times 0? Because double colon I can use only once in my address. Okay. Or what I can do? I can shorten it like 2001 colon 0 colon 0 colon db8 double colon 1. These both are the same addresses. Okay. We cannot shorten it like, if we try to shorten it, let's say, if I do not use double colon once, what will be the problem? So according to that, it will be shortened like 2001 double colon db8 colon again colon 1. If I do not use double colon only once, means if I use both the places. So what will be the problem in this case? The problem will be, let's say your system knows in IPv6 there are 8 hex states, right? So if you consider this hex state, this address, it will consider 1, 2, 3, 4, 5, and 6. So how many hex states are remaining? 2. So those 2 are 0. So this will be the same address. Here it will count 1, 2, 3, 4, 5. Means how many hex states remaining? 3. So those 3 are what? 0. But if you check it here, 1, 2, 3. Now 5 hex states, they are 0. So it can have like 1 and 4, 4 and 1, 2 and 3, 3 and 2. There can be certain possibilities. So every time it tries any combination, this will confuse your system and the address will be completely changed. So for this reason, we can use double colon only once in an address, so that there is no confusion like this. Because your system can consider this address something like 2001 colon 0 colon 0 colon 0 colon 0, then DB8, then colon 0 colon 3, 4, 5, 6, 7, 8. Either it will consider like this, or it can consider 2001 colon 0 colon DB8 colon 0 colon 0 colon 0 colon 0 colon 1. Because in the double colon, we only specify that continuous zeros are there. So your system doesn't know where are 2, where are 3, where is 1, where is 4. Okay. Or it can make a guess like 2001 colon 0 colon 0 colon DB8 colon 0 colon 0 colon 0 colon 1. This is our address. But there is one more possibility, 2001 colon 0 colon 0 colon 0 colon DB8 colon 0 colon 0 colon 1. Like this, it will have certain possibilities if you use this kind of thing. So this is not supported. This is not correct. And for this reason, but double colon can only be used once in an address. This is clear. So shortening method clear? Any doubt? No? Online people?
No.
Okay. Okay. Then after this, what we have? Types of addresses in your IPv6. So in your IPv6, we are having certain types like your global unicast, unique local, link local, multicast, and anycast. There is no broadcast in your IPv6. There is no broadcast in your IPv6. So first of all, what is global unicast? So these are like your public addresses in your IPv6, IPv4. So if we consider about your public addresses are globally unique. So these are the addresses with the name global unicast. Means these are globally unique. Second thing, these addresses are routable on the internet. Means publicly routable. Because your public IP addresses, you can use internet, right? So we can use internet in IPv6 using these addresses. This is clear. Then the second type is unique local. So these are acting like your public addresses in your IPv4. These are acting like your private addresses in your IPv4. So the private addresses, they are unique only in LAN and they are not routable on the internet. Similarly, your unique local, they are routable only in the LAN, not routable on the internet. Okay. So for local area networks, you can use the range in your unique local. Then they have link local. So link local is what? This is unique only on the link. Means, for example, this is a router and it is having 3 connections. So if there is a link local address on this particular interface, that will be unique only on this link. The same IP address, same link local address can be used here also. And same link local address can be used here also. There will be no problem. Why? Because these link local addresses, these are only unique on the link. These are like your APIPA IP address, automatically assigned. In your IP4, we have APIPA. So whenever DHCP is not having IP, they will automatically assign the IP address. Okay. Yesterday we see it, right? About APIPA. So the same thing. These are not routable, but these can be used to have connectivity and they are automatically assigned. So if you check here, see, this is not connected here, my network interface. But if you check, if I go to the IP version 6, okay, it will not show here. It needs to be connected. Okay, consider this Wi-Fi. I'm using IPv4, right? And if I start IPv6 also, right now IPv6 is not started. And now if I start IPv6 also, you'll see I do not have an IPv6 address, FD. Oh, I'm getting from my DHCP server, not this. Okay. So you see, it is directly giving me just link local address, only link local address. Why? Because I haven't assigned any global unicast or unique local link. Or even more simple, if you want to understand, let me just open packet tracer. So in packet tracer, I will just take a PC, will not assign any IP address. And you'll see the your link local address will already be present there. I will simply take a PC. I'm not assigning any IP address. And if you see in the IP configuration, the link local address is already present. Why? Because it is automatically assigned. Even if you don't assign any IP address to your router switch, they will automatically take this link local address. And this link local address, it is unique only on the link. Okay. Then we have multicast. Multicast is similar to your IPv4 used for communication between one to many. Like in your IPv4, the class D is reserved, right? Class D is reserved for multicast. Here, this multicast is having a separate group, separate range. Anycast is again when multiple systems use same IP address. So you'll see the range of your anycast and global unicast is the same. Why? Because it is one-to-one communication only, same like your unicast. But the thing is, here we can share the IP address, single IP address among multiple devices. So this is shared address. Okay. About anycast, we studied in our second or third session, I think, that what is anycast? Multiple hosts on the network will have the same IP address and the packet will be delivered, the message will be delivered to the nearest host. So this is how it works. Clear? All right. So these are the ranges of your global unicast 2000:3, and for your unique local, the range is FC00:7. Means if the IP addresses, they are starting from these ranges, that means you can easily identify them. Like your link local is starting from FE80. So if you check in the packet tracer, starting with the FE80. So looking at FE80, you can decide, okay, this is a link local address. Okay. And if you see anything starting with 2000, 2001, 2002, means that is what? Your global unicast address. And if some address is starting from FC00 or FD, that means that is your unicast, unique local. Then FF00, these are multicast addresses we do not assign. These are used for internal communication. Okay. And anycast, it is similar to your global unicast. Clear? Any doubt? Online people?
No, Ajay.
Okay. So now we'll see that if this PC is automatically getting this address, this link local address, so how it is generating this address, we'll see. Okay. So conversion of MAC address to link local address means your system, they will convert their MAC address into link local address. And how they will convert? So first of all, I'll take the MAC address of this system. So this is the MAC address. I'll copy it. Conversion of MAC address into link local address. So the MAC address right now we are having is, this is the MAC address. So the first step would be add FF:FE in the center of MAC address and replace dot with colon. Okay. We have to add FF:FE in the center of the MAC address and we have to replace the dot with colon. So this is my MAC address. In the center of this MAC address means here, I will add what? FF:FE. Add it. Now I'll replace these dots with the colons. Done. This is clear. Okay. Now next, what we have to do? Invert the 7th bit. So if we start calculating the bits, so first part will be having 4 bits. Second part will be having 4 bits. So means my 7th bit will be in this second part. Correct? Yes or no? Because each and every part is having 4 bits. This is having 4 bits. This is having 4 bits. So I just need to invert the 7th bit. So means if I write it in binary, this will be 0000 and again 0000. Correct? These two values. And where is the 7th bit? 1, 2, 3, 4, 5, 6, 7. So this is the 7th bit. So invert this bit means if it is 0, make it 1. If it is 1, make it 0. Okay. So means if I invert this bit, this will be 0000 and then 0010. Correct. So if I make it 10 and convert it back to hexadecimal, what will be the value? This will be 0. This will be 2, and then remaining part will be the same. We just need to invert the 7th bit and convert it back to hexadecimal. Okay. So how it is going to be? convert back to hexadecimal. So this will be 0, and after conversion it will be 2, and then 1 0, and remaining address will be same. So I'll just copy out this address, paste it, and this will be 2. Clear? The next step is add FE80 double colon in the beginning. Okay. And if you do this, your address will be FE80 double colon. So according to our calculation, this is the address. Correct? Let's check and compare it with the packet tracer address. Desktop, copy, paste. Compare these two addresses. This is the one in the packet tracer. Okay, and they have eliminated the starting 0. So this is the address. Now you can compare. Any changes? No, this is the same address. So this is how you convert your MAC address into link local address. Means we do not need to convert. We just need to understand how your PCs or routers, they are creating the link local address automatically. So they are just using their MAC address and they are converting it to the link local address. Is it clear? Any doubts? Online people?
No, Ajay.
Clear to everyone? Okay, noted. Okay, so next what we have, the features of your IPv6. So in your IPv6 there is no broadcast. Okay, and in your IPv6 we have auto configuration for stateless and stateful. Means you can assign the IP address from the DHCP as well as your IPv6 has a feature of automatic configuration. Means they will automatically configure an IPv6 address. Your host, they will automatically configure an IPv6 address. Okay, then in case of IPv6, like in your IPv4, we have NAT and PAT concept. So what was happening why IPv6 was designed? Because your IPv4 was getting exhausted. So when they were creating the IPv6, they kept all the things in mind. Whatever problems they faced with the IPv4, all these problems they already worked in the IPv6. Okay, so like NAT PAT concept, it is there in the IPv6, but it is not required because the number of addresses is already so big. Clear? Then has native support for IPsec. This IPsec is a security protocol. Okay, so it is already supporting this protocol. In IPv4, you will study this protocol in your VPNs. Okay, when you study in your when in CCNP, when you study about your VPN, about the IPsec VPN, you'll study these protocols. Then it has improved header. Means again, whatever problems were there in your IPv4, all those problems were improved in the IPv6. The header of your IPv6 was also improved. Then Anycast support, your IPv4 doesn't have Anycast support. The IPv6 Anycast is a feature of your IPv6. Okay. Now we'll see how to assign these addresses, how to assign IPv6 addresses, and how to do the routing in IPv6. I will take one host. First of all, let's see how to assign the addresses, and then we'll see how to assign it. One thing also you must understand, in your IPv6, mostly we'll be using /64 only. Means, see in your IPv6, what happens if I write an IPv6 address? So what are the parts in this IPv4 address, IPv6 address? So whenever you request your ISPs for an address, okay, so they are going to assign you /48. Okay, means let's say I want a public network global unicast range for my company. So they will assign me /48. Okay, ISP will generally assign /48. Okay, now how they are going to assign? Let's say you would ask for a network and they gave you 2001:0DB8:0017. They gave you this range because 16, 32, 48. They said /48. This network you can use. Okay. Now what you have to do, you have to design different subnets. You have to design different subnets because in your company you will not be having only one network. You can have multiple networks. So how you can design subnets? So end hosts are assigned with /64. we are mostly going to use always /64. Okay. So means, see, again, slash notation is same here. In front of slash, we'll be writing number of network bits only. Means this part is the network. Okay. And when we do subnetting in the IPv4, so there is no subnetting in the IPv6. If you want to change the network, if you want to like subnet, if you want to create a subnet, how you can do it? You can do it like 2001 colon 0 db8 colon 0010. Now the first subnet you can design is 0000 double colon /64. This is one network because you made it 64. So earlier only this part was network, and now this part is the network because we said /64. Now the next network, let's say for second department you want to design a network, so you'll say 2001 colon 0 db8 colon 0010 0001 /64. This is a new network, correct? Similarly, this can go until 2001 colon 0 db8 colon 0010 colon FFF, maximum value, because your ISP gave you this network. Now in this network you are designing different subnets. So how many subnets you can design? How many bits are there? 16 bits, right? Your ISP gave you 48, you are using 64. Means how many bits you are manipulating? 16 bits. Means 2 raised to power 16 subnets you can create in one network. That is 65,536. 65,536 subnets you can create in one network. Okay. And how many hosts? So for calculating number of hosts, what we do? 2 raised to power number of hosts. Correct. So if 64 are network bit, out of 128, 64 are network bits. How many host bits are there? Again 64. So 2 raised to power 64 hosts can be accommodated in one network. So you can see even your complete IPv4 is 2 raised to power 32. And in one network of your IPv6, you can have 2 raised to power 64 addresses. That is far more, right? And this is the reason in IPv6, it doesn't matter how many addresses you waste, because even if you are using 2 IPs, you can use /64. Even if using 100,000 billion IPs, you can use /64. Okay. So it doesn't matter in your IPv6 how many addresses you waste. Is it clear? So means to the clients, we are always going to assign /64. This is clear. Okay. And for creating the subnets, I will be changing this 4th octet. So means if you consider your IPv6, these 3 octets, these are the network. These are for the network. Then this 1 octet. This 1 octet, it is the subnet octet. Means if you want to change the subnet, you can change this octet. And remaining part, remaining all the octets, they are the host. Yes, there is. See, in IPv6, even that will become more simple. How? Let's say I have to write network ID. So this is my network ID because the company gave me. This is a network ID. If I'm designing subnet, so host part, I'm making all zeros in the network ID. So all zeros means replace with double colon. So these are all network IDs. So when we are doing the routing, we'll see how to design the networks and how to define the network IDs and everything. And routing in IPv6 is even more easy than your IPv4. Okay, you'll see that. This is clear. Any doubt so far? That 3 octets, they are for 3 octets, they are for network. 1 is for subnet, and remaining 4 is for host. Is that clear? Okay. So let's say I want to use here the network 2001 colon. If I say 2000 double colon /64, this is the network. How? Rest of entire part is 0. Okay. So means if I want to assign first IP from this network, so what can be that IP? That can be 2001 double colon 1 /64. This is the first IP. Because I'm just changing the last part. You see last octet. And last octet is what? Host. And remaining all the octets in between, they are network. Means 64 means 4 octets are network. You write.
Subnet part can be 0 also.
Yes. Because the first subnet we are designing, only one subnet we are designing. From this network, let's say what if you write this in the detailed form, so this will be something like 2001 colon 0000. So this is your network. This much part is your network with the subnet. Correct. Now we want to design the first IP of this network. So for designing the first IP, what I can do? I can just change the last host hexstate. This is my first address. If I replace all these continuous zeros with double colon, this will be my address. Yes or no? If I shorten this address 1, 2, 3, 4, 5, 6, 6 are continuous zeros. So 6 hex data I replace with double colon. And here I remove the starting zeros. So this is 1. And we are always going to use /64. So this will be /64. This and this address, they are same. Now I want to use for the client also. So I'll say 2001 :2/64. This is it. This is subnet mask, right? /64. Only slash value, no subnet mask concept. Okay. Only slash value you have to use, no subnet mask concept. Okay. Even if you check in the PC, you don't have anything like in your IPv4, we are having subnet mask option. But in your IPv6, we are only having slash option. So we have to write only slash value. Okay. And even if real Windows system, if you check, if I'm going to Ethernet in the IPv6, if you check, if I say use the following IPv6 address, so it is saying subnet prefix length, not subnet mask. And if I give any address here, 2000:1, and if I give tab, it is automatically taking 64. Okay.
So this slash value, can we change this?
Yes, you can change this.
Like subnetting.
Yes.
We can do
See, in IPv6, if you want to do subnetting, all you have to do is just change this hex state. First hex state, you keep all zeros. That is one network, you keep it 1. Second network, you keep it 2. Third network. No need to go with the different subnet mask. Always use /64 and keep changing on this hex state, and you will be doing subnetting. You don't even know. No need to have extra concept. Like we will be having network bits, host bits, then we'll be calculating subnet mask, nothing like that. This becomes more easy in your IPv6. If you change this 4th octet and use /64, first is 0, first network, 1, second network, 2, third network. This is so easy to design. Okay. Is it clear? Okay. So now assign the IP addresses. Go to the PC. All you have to do is 2001:2 and say 64. IP address assigned. Okay. And router IP we can give in the default gateway. So 2001:1. That's it. Go on the router. CLI. Say no. Enable. Configure terminal. Interface Z0/0. Then we have to assign IP address. So we'll say IP address. This is what we did in case of IPv4. Only change that will come in the commands is any place you use the word IP, instead of IP, you have to use IPv6. That's it. This is only the change. Any place you use the word IP, like show IP interface brief. So instead of that, show IPv6 interface brief. IP root, IPv6 root. Means any place we use the word IP, we will replace that word with the IPv6. So instead of IP address, I'll say IPv6 address. Then assign the address 2001:1/64. Address assigned. Okay. Say no shutdown and the interface will be up. So it is
Works at the interface level.
everything. Double colon will work everywhere in your IPv6. Okay. Now check ping. Check connectivity with the PC. So you say ping 2001:2 and ping works. Clear? So they have the connectivity. This is clear. How to assign the addresses. All you have to do is just replace the word IP with IPv6. That's it. This is clear. Now we'll see how to do the routing. So in the routing, we'll see only static and default route. Dynamic routing you will be seeing in your CCNP. Again, you have IPv6 in your CCNP. Okay. For this purpose, I'll take 2 routers. I'll connect them. Okay. Here I'm going to use the network 2001:/64. Okay. This side I can use. See, if I want to do the subnetting, I'll be using now 2001:0:1/64. Sorry, double colon. This will be my first subnet because in this all zeros, here I have given all 0:0:0:1. Then next will be 0:0:2. Then next will be 0:0:3. But if you want to make it more easy, you can do it like you can completely change the network 2002:/64. If you want to understand the routing, you can make it more easy. Okay. Then 2003 :/64. And you can have 2004 :/64. Let's say these are the addresses I want to use as a loopback. This is R1. This one is R2. This will be 2001 :1. This will be 2002 :2. Sorry, 2001 :2. So we'll be seeing about static and default route. Go to R1. No. Enable configure terminal. Hostname will be R1. Interface 0x0 IPv6 address. And you'll say 2001 :1/64 and no shutdown. Done. Configuration of R1 is complete. Go to R2. CLI. Say no. Enable configure terminal. Hostname R2. Then say interface 0x0 IP address, IPv6 address 2001 :2/64. Say no shutdown. Then give some loopback interfaces. So interface loopback 1, IPv6 address 2002 :2/64. Interface loopback 2, then 2003 :2. Interface loopback 3. This will be 2004 :2. Address is assigned. Now, if you want to check the routing table, and before routing table, if you want to check the IP addresses, so we gave the command show IP interface brief, right? Instead of it, the command will be show IPv6 interface brief, and you'll see this is the link local address starting with FE80, and this is the address we assigned. So you see they are automatically taking this link local address. We haven't assigned anything. Okay, and these are the addresses we assigned. If you want to check the routing table, we were saying show IP route. Correct. What we'll say? Show IPv6 route, and you'll see all the connected networks. So 1, 2, 3, and 4. 4 networks. 2001 :/64, 2002, 2003, 2004. Correct. In case of R1, you'll see R1 is not having routes for 2002, 3, and 4. If you check, show IPv6 route, you see it is having route only for 2001, no route for 2002. So if I try to ping 2002 :2, there will be no communication because no route, no communication. So we have to define a route. Okay. To define a static route, what we used to say in case of IPv4, command was IP route. Okay. Instead of IP route, what we are going to say? IPv6 route. Now we used to give the destination network. So what is the destination network here? 2002 :/64. This is the network, and subnet mask also done because we gave the slash value. Now give the next stop address 2001 :2. Done. Let's check the connectivity. So first of all, let's check the routing table. So do show IPv6 route, and you see now we have a static route with the code S for the network 2002 :/64 via correct. Do ping 2002 :2, having the connectivity. Static route is clear. Default route is even more easy. Right now, if you try to ping, do ping 2003 :2, no communication because no route in the routing table. Okay. So in default route in IPv4, what we used to say, IP route, network part all zeros, subnet mask all zeros, and then the next stop address, right? Similarly, you are going to say IPv6 route. Now, whenever we are talking about all zeros in case of IPv6, what we can do? Replace with double colon. Mask is also 0/0, and you can give the next stop address 2001 :2. This is default route. Means always you have to say IPv6 route /0 and give the next hop address. That will be your default routing in case of IPv6. Okay. So now try to ping. If you try to ping 2003:2, you have the communication. Also 2004:2, you have the communication. So this is how you do static and default routing in case of IPv6. Is it clear? Online people? Any doubt in this part? Clear to everyone? Okay. So IPv6 and routing is clear, right? Okay. Then next we have introduction to campus networks. Okay. So what are these campus networks? There's no configuration, only theory part. Let's say I have a company, and in my company, I'm having certain buildings. Okay. And this is one building, and this is second building. Each building is having some sort of departments, right? So let's say in each and every department, I'm having some switches. For example, let's say 2 switches. Okay. And in the departments, there are PCs connected. Correct? Okay. This is done. Now I want to manage these. I want to manage these departments from a centralized place, from one location. So what I'll do, I'll use a switch. And what I'll do, I'll provide connectivity to both these departments. And I'll be able to manage these switches from a centralized place. Correct? Similarly, on the other building also, the same scenario will be there, because there will also be departments. And they will be managed from central place. Correct? Like this. This is clear. Now these 2 buildings, they belong to the same company. So they will have only one server room. So means again, we have to centralize them. So I'll use one more switch, and one from this building and one link from this building. Done. And I'll use a router for the internet connectivity, and I'll provide the connection. Now both the buildings are able to use the network. Correct? And let's say this is connected to the internet. Okay. Well, done. Now what will happen if this switch goes down? What will happen? If this switch at any point of time it goes down, what is going to happen? My entire building is down. My entire building network is down. So for redundancy purpose, what I'm going to do, I'm going to use here one more switch as a backup switch. Okay. And I'll connect them with both the departments and provide connectivity between the switches for load balancing, so that one switch will not have all the load. Okay. Similarly, I need in this building also, because if this switch goes down, again, entire building is down. This is clear. Now I'll provide connectivity from this switch also, because at any point of time, this switch goes down, and if I'm not having the connection directly to this switch, again, it is down. And similarly, I will have a connection here as well. Correct? Now this is the switch in the server room, my core switch. So if this switch goes down, both the buildings will go down. Means I need one more switch for the redundancy purpose. Okay. And what I'm going to do, I'm going to provide connection to each and every switch. Done. Now we have full redundancy. But again, I have only one ISP. If my one ISP goes down, what will happen? Again down. So I'll take a backup ISP also. And I'll have connection to the internet through this ISP also. Okay. And I'll connect these 2 routers as well, so that they will be continuously communicating with each other. And this is what a 3-layer design is. It is known as campus LAN design. So in the campus LAN design, we have 2-layer architecture and 3-layer architecture. So in the big buildings, I mean, in the big companies where they are having multiple buildings, this 3-layer architecture is used. In this 3-layer architecture, different layers of switches are there. Okay. So the first layer, where the end hosts are connecting, these switches, these are known as access layer. These are known as access layer. This is the layer where your end host, your PCs are going to connect. Okay. Clear? Okay. Next is the second layer. This is known as distribution layer. So whenever your traffic has to go from one department to another department, you'll see that traffic will be distributed by these switches. Correct? because they don't have direct connectivity. Your access layer switches will now never have the direct connectivity. They will go to the distribution layer switches and they will distribute this traffic in the different departments. So these are known as distribution layer. And the switches who is centralizing your entire network, they are known as core layer. And these are the fastest switches in your network. If you are having, let's say, 1 Gbps, these are the 10 Gbps. Because you see, entire traffic from both the buildings, if some traffic is going from this building to this building or this building to the other building, or it is going to the internet, entire traffic is traveling through these switches. So they have to be fast. Otherwise, there will be delay in your network, delay in communication. Okay. So these are the fastest switches. Is it clear? 3-layer architecture is clear. Now, what about the companies who don't have multiple buildings? Yes, who don't have multiple buildings. So what is going to happen? They don't need this centralization. The core layer centralization, they do not need. Because if it is only one building, means I can centralize from one place only. Right? So 3-layer architecture is clear. 3-tier architecture. Okay. The second is, if you have only one building, again, you can have the same example. Let's say these are the access layer switches where you are going to connect the end host. Right? Then to centralize them, you will use a switch. And that switch is going to have traffic from both the departments. But again, for redundancy, we'll be using one more switch. And you connect them like this. But I do not need no more centralization. I am not having any other building. Okay. So what I'll do, I'll direct connect to ISP. But for redundancy purpose, so that my one ISP goes down, I can have another. I will use one more router. Means same scenario, but we will just merge the core layer and distribution layer. Okay. And this layer will be known as collapsed distribution core layer. And this is again your access layer. So your end host, they will be always connected in your access layer. So whenever you see the word access switch, that means we are talking about this switches where we connect the end host. Okay. And whenever we are talking about core layer switches, means we are talking about the high speed switches. Okay. And then these are the ISPs. These are the routers connecting you to the WAN. So this is your 2-layer architecture, means only 1 and 2 layer. Is it clear? So 2-tier architecture and 3-tier architecture is clear. But if you see in these architectures, entire data is traveling either switches to router, router to switches. Means we can say the data is traveling from north to south or south to north. Correct? If you see the direction, this is how we write, right? East, north, south, west. So data is traveling up and down. Means north to south or south to north. This is clear. And in this, we can have some latency. We can have some delay because the data is traveling. Let's say data has to go from one building to another building. So that time, what will happen? It has to travel from certain switches, then again travel from many switches. If you see the 3-layer architecture, from access to distribution, distribution to core, core to again distribution, then again access, and then to the node. So this may take some time. So there is latency in your campus LAN designs. Okay. So in data centers, latency cannot be afforded because in data centers, the data is being stored and the data is passing. So we cannot have the latency. Okay. So for data centers, we have a separate design. That design is known as spine and leaf. Spine and leaf means there will be one layer of switches. There will be one layer of switches. These layers will be known as spine layer. And these layer will be connecting. Let me just create 2 only. To the leaf layer switches. So leaf layer are again like your access layer only where you connect the host. But in case of data centers, we do not use the host. We use data servers. The servers that are going to store the data. Okay. So means they are going to store the servers. And all the spine layer is connected to the leaf layer. This is how the design is. But in this, you have a better option to expand. Means at any point of time, you want to increase the size of your network, you can just add one more switch, add some servers, and just give the connection. Okay. At any point of time, you see the spine layer switches are having higher load. Just add one more switch and give the connections. That's it. Is it clear? Okay. So now we'll see about this. So in this spine and leaf architecture, we are having less latency than your. So this is the 3-layer architecture. We are having access layer where we connect the devices. We are having distribution layer that is going to have connections to all the access layer switches. And we are going to use a core layer for centralizing different buildings. Is it clear? Then we have a 2-layer architecture. So smaller companies, they cannot afford these kind of big networks. So they will always go with the 2-layer architecture. Okay. So in this campus network, the data flows from north to south and south to north. For data centers, we have this design, the spine and leaf. So in spine and leaf architecture, the data flows from east to west because one server to another server, it will be flowing because always data is never stored in one place. Let's say I'm using a website. I'm using a Google service, right? I'm having emails. I'm having online storage. So if I'm sharing this storage from with you, so what you guys are doing? Let's say I'm sharing Google Drive access to you. So again, you are accessing from my server only. Okay. And if you are copying it and downloading it in your system and then uploading again in your server, in your drive, same thing. Again, from one server going to another server. Okay. So in case of spine and leaf, let's say bigger applications like Google is not a small application. Okay. So they are running servers from different locations. They're having multiple servers, big data centers to store the data. So ultimately, the data is traveling from one server to another server. It means the data travels from right to left or left to right, or you can say east to west and west to east. And in this, only 2 layers are there. So there is less latency compared to your 2-tier and 3-tier architecture. Is it clear? Now, let's say the company is even more smaller, not a data center, not a small company. Let's say we are work from home company. Okay. So for that, we have a small architecture that is SOHO architecture, small office, home office architecture. Okay. You take an internet connection from your ISP. They will give you a router. You connect a switch. With the switch, you can connect your devices. And if you want wireless range also, you can connect access point. Okay. And that is going to provide you the wireless range and you can connect. And even more smaller these days, we are having from the ISP. You take a connection, they will give you a Wi-Fi router. They will give a Wi-Fi router. Now in this Wi-Fi router, there will be 3 or 4 ports also available. So if it is just 3 or 4 devices, you'll just connect them with the LAN, and the wireless devices you will direct connect with the wireless. Okay. So this is your small office, home office architecture. Means if you are working from home or if you are running an office from home, small office. So in that case, we have the SOHO architecture. This is clear. Any doubts?
See, in the spine and leaf architecture, is all the leaves connected to each and every spine, all of them.
All of them. They are connected to all of them. Okay. So any doubt in IPv6 routing or these architectures? No? Online people? Okay. Then we are done for the day. Have a great day, guys. See ya.
Bye.
Let's say I'm requesting an IP. Okay. So if I'm having only one department, then my ISP, let's say, gives me 2001 colon 10 colon 1 double colon slash 48 because ISP will give me 48 only. So if I want to design first network, what I can do? If I'm having only one network, I will directly start assigning IP addresses to my clients. So I'll say 2001 10 colon 1. Then instead of changing anything in between, I'll just change the last part for easy understanding. So means 0 0 0 0 1. This is my first IP. Then for second IP, I'll say 2 3 4 5. Correct. But now if I want to change network, so ISP has given me this part. And if I use /48 mask, I will have to change in the third extent. But on clients, I generally use /64. 64 means I have one more option. Because if I change this, means I'm changing the network ISP provided me. So I cannot use ISP provided network. So only one network I'll be using, the provided with the ISP. So for my understanding, for my networks, for subnetting, I'll use only 4th octave or 4th extent. If I change the 4th extent value, the first value will be 0000, 0001, 0002. So these are different networks because we are using /64. Right? So maximum I can make FFF. So these many subnets I can design. Now from these subnets, let's say I want to give IP from this. I have already given this. From the second subnet, I want to provide IP. So my IP will be 2001:10:1:1:1 means remaining all zeros in between. This will be my first IP. If I want to assign some IP from this, it will be 2001:10:1. I cannot change this because this has been provided by the ISP. I can just change my subnet part. So means these three parts will be same because they have been provided by the ISP. For subnetting purpose, for creating different subnets, we will change only this part. Okay, and this complete part is the host. So we can have, if I'm changing this part, I will have to write a bigger address because I'll have to write, let's say 1:2:3: again 1. But if I'm keeping these zeros, means I can replace with double column. Okay, any doubts? This is clear because we will always try to keep our IPv6 address as short as possible. This is the main motive because we don't want to write a bigger address. And if it is a small address, it is easy to understand also. Like for the example, I kept just 1001, so 2001:1. So this is short, easy to understand. But at the same time, if I keep the address something like 2001:0DB8:0ABC:01AB:, so this will be a complex address. Also to remember, also to configure. Okay, so to keep it simple, we'll always try to keep it short. Clear? No, it can go up to /128 also. But for our understanding, for keeping a general record so that we can easily understand and we can relate it, we will always use /64. Because again, if we will keep going, let's say after 64, we'll be having around 72, I think, 82. 16 if we add 80. /80. Next will be, what will be the next value? 64 plus 16. 80. So means if I use /80, this much part will be the network. If I use 96, this much part will be the network. So that depends on me, how complex I want to make it. We can use this. If we use this, means we are just dividing this part into half. Half part is the network, half part is the host. Easy understanding. Is that clear? Any more doubts? No? All right.
Which part would be the subnet?
See, higher slash values means if you use 80, this will become your subnet. Also, this is your subnet because you will get 2 exits. This is again fixed with the company. Now you have to, if you are using 96, these 3 will be the subnets. Yes. So again, if you are using these 3 also, you can have the first subnet as 000000000000. Next subnet 1, next subnet 2. Because if you manipulate more and more hex states, that will make it more complex. Okay. So for that reason, always use /60. Is that clear? All right. Let's see you guys tomorrow. Have a great day.